So absolute value. If you're looking at something like the absolute value is less than -5, you got to ask yourself, what numbers can you take their absolute value and have results less than -5? And the answer pretty clearly is none. There are no numbers whose absolute value is less than -5. So your solution set for that first inequality is the empty set. How about the second absolute value? Absolute value is less than 2. What numbers have an absolute value who's less than 2? And if you think about that, just absolute value-wise, you're going to say, hey, any numbers between -2 and 2, exclusive, any of those numbers are going to have an absolute value less than 2. Third one, suppose you want the absolute value greater than or equal to 4. Okay. You could have numbers less than or equal to -4. Those are good. And then you can have numbers that are greater than or equal to 4. And those would be good. So, consider a specific example like the absolute value of 2x minus 7 is less than 2. You're looking for numbers whose absolute value is less than 2. So go ahead and say, well, what are those numbers? Those would be numbers between -2 and 2. What numbers? 2x minus 7 has got to fall between -2 and 2. Go ahead then and isolate x in the middle, and you get x is between 5/2 and 9/2. So a geometric interpretation for absolute value is, if I'm looking at the absolute value of some number a, I'm asking, and I need that absolute value to be 3, I'm asking what points on the number line are 3 units away from 0? And my answer would be, well, I've got 2 points that are 3 units away from 0, -3 and +3. So the absolute value of a, then, geometrically, is what's the distance from 0 to a. And if I want that distance to be 3, I can visualize it. So for the second one, I want the distance from a to 0 to be less than 3. What numbers on the number line would have a distance from themselves to 0 being less than 3? Well, clearly it would be all the numbers in between, excluding -3 and 3. And the last one, geometrically speaking, I want the distance from numbers a to 0 to be greater than 3. What numbers would those be? Those would be the numbers less than -3 or greater than 3. So, suppose we have something like the absolute value of x minus 3 is less than 4. When I replace x with x minus 3, what I've done is simply translated my point of reference 3 units to the right. So, what I'm really asking geometrically for this question is, rather than the distance from x to 0, now I'm looking at the distance from 3. I want the distance from x to 3 to be less than 4. So what points on the number line are within 4 units of 3? And I can do that by simply counting 7 and -1. So my answer here would be, I'm looking for the numbers between -1 and 7. Okay, so again, a problem like this, if I've got simply a translation, and that x plus 7 is going to be simply a translation, I'm looking at the distance from x rather than to 0, I'm looking at the distance from x to -7. So if I consider this, say, okay, from -7, I want the distance to be greater than 8. So if I go 8 units on each side of -7, I can then count out and get to, let's see, 8 up would take me to 1, and 8 down would take me to -15, and I answer the question then. X has got to be less than -15, or x is going to be greater than 1. So viewed just from a translation point of view, I simply can do some counting geometrically and answer the question.